My name is Steve Guttenberg, and I'm the Audiophiliac, and I'm back here practically in the same exact spot. It's either 1 year ago or 2 years ago.
It's 1 year.
You're sure?
Yeah, we checked.
We checked? All right, all right. So a year ago, here we were making a video, and you had just gotten the job, though.
At Soundsmith, yeah, I just got hired as an engineer.
You're telling me you're up to the point now that you've actually designed a cartridge on your own? Not to sell, but for yourself?
Well, we've been playing around with prototypes, and I have, since I've been working on assembling cartridges, of course I'm going to play around with the parts. I'm an engineer,
Right.
and that's just in my nature. So I've done a few interesting experiments on my own. Peter would probably not be happy to hear that, but maybe he would.
Frankenstein cartridges.
Frankenstein cartridges. I took a couple pictures of those as well.
But seriously, because I think you'd be the ideal person to ask this question. So when you're designing a cartridge, right, what are you moving towards as the design evolves that makes it sound better?
Well,
What is the difference between let's say an expensive cartridge, more than $1,000 cartridge? What would be the thing that would make it sound better than less good? What is it that makes it better?
yeah. Well, the major proponent in phono cartridge performance is the moving mass. Since it's a mechanical system, an electromechanical system, and you basically want to minimize the amount of moving mass and generate a highly reactive system based around low moving mass, which is extremely challenging, especially as we get into micro materials and science. Physics behave very differently on such a small scale. It's kind of stuff that works in theory doesn't translate to things that work in practice.
Okay.
So minimizing the moving mass is the first thing. That will reduce stylus jitter drastically and increase high frequency performance, high frequency tracking, and lower groove noise. Basically, every positive aspect of a phono cartridge is correlated to the moving mass. That's the main goal, is to minimize that.
But isn't there geometry involved, and isn't there the stylus shape and
there's
the
stylus,
length of the cantilever?
stylus profile and geometry. You basically want to get the best purchase of your ultralight stylus in the groove, and the rest just comes after. Physically, in a literal sense, it's after the stylus. You got your generator to produce a voltage. In the case of our strain gauge cartridge, there is no generator. It's modulating a voltage, and that's a cartridge with virtually no moving mass. It's just a cantilever, basically. And it's really cool to see something like that and being able to work around it and set them up at shows. It's a lot of fun. And it's humbling to understand that I'm being able to work with such an awesome design, and I'm extremely thankful for that. Peter's really kind.
But that's it. Well, that's all. That's what makes one cartridge better than another, is lower moving mass.
That's the major thing you want to look for in a phono cartridge, is the moving mass.
And so there was a thing there of making cartridges with shorter and shorter cantilevers.
Yeah, I've seen a couple that will certainly decrease the moving mass since you've got physically less material.
Right.
But
And it's
cantilever,
stronger because it's shorter. This cartridge with really long cantilevers, which always seem kind of weird, right?
It's a trade-off because the cantilever, as its name implies, it's a force multiplier. So in your groove, there's a certain amount of displacement at the stylus, and then you have a certain amount of displacement at the other end, which is your generator mechanism. So the cantilever is kind of the governing factor of how much voltage you're going to generate at the other end and how much the other end has bearing on your stylus jitter, how much your moving mass has bearing on the stylus jitter. So the short cantilever will increase rigidity and decrease moving mass drastically, but there's also trade-offs because now you're going to have greater displacement at your generator. Your generator is going to be reflecting more energy back down, so you got to find a compromise of it's a ton of factors. It's really mind-blowing.
Yeah.
Everything in engineering is a compromise.
Right.
So if they can get a short stylus to work, short cantilever to work, that would be a really good way to do a phono cartridge. It's just really, really challenging, everything about it.
I think everything about playing records, designing great turntables, arms, and cartridges is extremely challenging. I mean, the funny thing is that superficially, a turntable looks really simple. Okay, it's a platter, a motor that spins the platter, a bearing, an arm. Well, what's the big deal?
Yeah, in theory, one of my favorite sayings from Peter is he says, "It works in practice, but does it work in theory?" And that's really heavy for a lot of the mechanical and electrical sciences based around turntable design. And there's a lot more to it than just spinning at the right speed and getting the right geometry. There's mechanical impedance, which plays a huge role in stylus jitter. You basically want to match materials and get really good, consistent energy flow throughout the platter, the plinth, the tone arm. It's every material choice has bearing on the performance of the table.
So Lynn was the first turntable that I was aware of that, talked about this closed loop between the stylus and the groove and the cartridge and the arm and where the arm is attached to the plinth, and then through the subchassis up through the spindle back, so that everything is absolutely rigid except for letting the arm move across the record freely.
Yeah, your horizontal bearing has to have zero drag. Your vertical bearing for warped records has to have zero drag. So your generator is most likely going to be aligned at all times. The anti-skate also has a lot to do with generator alignment. That can twist your cantilever pretty bad without the proper use of anti-skate. The Lynn design is really unique because they used really high quality materials. I'm actually, as a manufacturer, I'm not supposed to talk about other equipment, but I really do love Lynn designs. I like their stuff.
Though they haven't done anything lately.
No, the LP12 is probably one of my favorite turntables in all of its states. They made a bunch of different versions. They're mostly the same. It's a generally high performance piece that I do enjoy working on.
Yeah, but the thing is, the company has lost, it appears, has lost its interest in making turntables. It's like, yeah, well, we make it and, we'll make some upgrades and charge a lot of money for them. But in terms of really being out there, it's funny because they're the company more than any other was the one that was like shaking things up in the 70s. Like, Ivor's thing was the turntable is the most important part of the system.
Well, the source, yeah.
The source, but that was a radical statement, because before they'd say, well, the cartridge is the most important part of the system because the cartridge is the part that's decoding the groove. And his thing, no, a great turntable with a mediocre cartridge sounds better than a great cartridge on a mediocre turntable, and it does. That's absolutely true. But when he said it, like, people said, no, it's all about the cartridge. And then we had all these demos back in the day to prove that that was the case. But, they're just not into it. And it's funny, when the whole turntable escalation started happening, Lynn was a no-show. Like, they could have been out there making great, budget turntables and exotic, and they just sort of sat it out. It was kind of weird.
Yeah, well, to just think about what they could be doing today.
Yeah, well, but they're clearly not interested, so it's kind of sad.
The same goes for Bang & Olufsen. They completely quit their turntable designs. They had some really innovative designs amidst some stuff that wasn't so great. But most of their stuff was really clever and intuitive, and a lot of their stuff hasn't been bested yet, which is pretty interesting. It hits a ceiling of evolution, and then it just stops. No one really tries to evolve it any further. Either because they forgot about it or they don't care.
Yeah, turntables are fascinating to me, because they seem so simple, and yet there's a lot going on.
There's just too much to mention in one video.
Okay, you want to stop? Is that what you're saying? But as someone who's lived with many turntables over the years, when you go from one to the next one. When I had a Roxanne turntable, I've had a few LP12s, I have an SME now, and before that I had a VPI. And when you go from one to the other, you just hear this massive change in the tonality and surface noise and rhythm, how exciting it is, how rhythm is communicated by different turntables. It's pretty extreme.
Yeah, a lot of that has to do with resonance, believe it or not, and the control of stylus jitter, and basically wicking the energy away from the cantilever as efficiently as possible. Again, with the mechanical impedance matching, you want to have depending where it is, you don't want to convert the energy into heat. You want it to get out of there as fast as possible.
I like that the way you just put it, wicking it away. That's a good way.
Yeah, it's that's something I came up with.
That's good. No, that's great.
It's an interesting way to describe the system of a stylus cantilever generator.
I don't think anybody's ever said it quite like that. But
yeah, and you're not going to get all of it out, and there is always going to be reflections. If you have any amount of moving mass, there's going to be inertia and jitter. The goal is to obviously minimize it as best as we can, but we're never going to achieve perfection. They do have actually laser groove measurement systems with turntables, but the problem I noticed with those is if you got a little speck, whereas a stylus would just push it out of the way,
right.
it would be huge pop in the speakers because it's not actually touching the
dust. Laser turntables go back a ways, and there was a lot of excitement when they first started to appear, like this is the perfect way, no moving mass. But the thing is, they just don't seem to have the resolution of a stylus in a groove.
It's a challenging, really challenging endeavor to scan something real time and transfer it. There's ways to do it in completely analog, which is totally a fascinating science. But again, with the dust, it's just inherent to the medium that you're going to have specks of dirt. We don't play in a clean room.
So what do you think? How do you feel about record cleaning machines? Because I don't get it, actually, to tell you the truth. I think this obsession, it's like a clean obsession that a lot of audiophiles have with like cleaning their records, and different record cleaning solutions, blah, blah, blah. And it's like, when I buy used records that are sort of iffy in terms of their cleanliness, I go to my sink, I have a bottle of distilled water, I pour the distilled water over the record, I take a tiny, tiny bit of dishwashing detergent, I swish it around with my fingers, I rinse it really well, I shake the record dry, and there it is. Now, does it sound as clean as an ultrasonic record cleaning machine? Probably not. But the thing is, why do you think clean records that are, let's say, between, let's say, acceptably clean, like my method, versus an ultrasonic, what do you think the difference is?
Well, I'm from a different state of thinking with that. What I understand is you're trying to lower the amount of noise that's outside of the music, which chalks up to dirt, pops, and groove noise. And what a lot of people don't understand about groove noise is that it's majorly stylus jitter. It actually doesn't have anything to do with the cleanliness of the record. If you have a blank groove, unmodulated groove, and a high-mass phono cartridge, it will put the cartridge into resonance, and you will hear groove noise with a perfectly clean system and no music playing. So, in order to lower your noise floor, cleaning is a step to get you in the right direction, but you really want to do it mechanically and solve the problem at its source instead of trying to treat the symptoms. We get records acceptably clean, free of dust, free of dirt, and we can most of the time have inaudible noise floors, depending on the recording. With 2 spin cleans, we bring those to shows.
Okay.
At Soundsmith, we have a VPI record cleaner that we use all the time, and we use it for its efficiency, and it works pretty well. We're happy with it.
Well, I think what you said, that a lot of what people perceive as surface noise is the stylus bouncing around.
Yeah, it's jitter, it's resonating. And
does that mean it's losing contact with the groove wall?
Well, that happens at high frequencies. Normally, you'll observe really good contact with the groove wall in a normal phono system up until the top end of the audible spectrum, where you'll be able to observe copious amounts of jitter as the stylus is trying to track, but its inertia isn't really letting it go back and forth that fast. So what it does is it ends up jumping out of the groove wall and banging down the
Really?
top end of the top end of the groove and sampling. We call it sampling the groove. It's not really playing
Wow.
what's actually.
And
in
this
it.
isn't a reasonably competently designed cartridge and a well set up turntable? Really?
Yeah, it's what we've observed.
Wow. We got to save the world from stylus jitter.
That is the goal.
Oh, I think that's a very that's something to shoot for. So, anything else?
Other than that, I don't think so.
All right.
I think that's everything.
You were so mesmerizing, I wasn't thinking about your friends in the mirror behind the thing. But, you know, in any case, I think our work here is done. My name's Steve Guttenberg. This is the Audiophiliac Daily Show with my special guest today, second appearance, Parker from Soundsmith. So check out their website. I will link to it below. And I'll see you next year.
Awesome.
Bye-bye.